remember one of the titles.
Hard to say myself.
I don't remember. So I ordered on that team. We should just take it with
Right, quiet. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Okay, if you haven't already, obviously we're going to be going over the photoelectric effect problem first. So, again, if you haven't already, please get that out. Remind me real quickly, Abby, what does this mean? What does this mean, Ada? Joanna?
Energy of the photon.
Energy of the photon, not energy. Energy of the photon, good. And of course this, Maria? Amplitude, okay, good. Okay, so let's go ahead and place them up. Put our answers up on the board, and I'm just thinking, you know what? I just did this in black. Hang on a second, guys.
Bright orange.
Yeah. I didn't know I was back so.
Well, bright orange. It depends how bright it is.
I have a hard time with the bright orange.
Because if it's like
It was like 10 years ago.
yeah, because you can't tell for bright orange, and you can't tell for dim green.
Okay. So like my parents were like talking really loud about chemistry.
Okay, yeah, I definitely do.
Yes! Oh my gosh!
We use red markers. Just make it easier to see it. Okay, volunteer. Who would like to go ahead and do the bright orange? All right, Kyle. Dim orange. Joe. Dim yellow. Carrie, all yours. Dim green. Dim green. All right, Hunter. Bright green. Hunter. You got dim green. Yeah, we're just gonna go up there and get them up there as best we can. Just work up there. Yep. Dim green, bright green. Okay, Noah. And bright yellow. Bright yellow. Yeah, how about the guy with the yellow hair?
What's up, Joe? You're on the wrong one.
I realized
How come we didn't do that part of it? So you did the, right, how'd you do this? This is the last one in the problem. Pardon me? And how do you not do the amplitude?
Oh, it doesn't matter.
I mean, this one, this is actually after.
It's the electron for Gemini. So. Oh,
Did we do the other side?
Yeah.
Well, I also said that my health makes the same.
Did you see what's going on? Yeah.
you said fan. Eric disagrees?
Hmm?
What did I say?
Come on, guys, Eric, finish up. You guys aren't paying the Sistine Chapel.
Excuse me, Ryan.
I said no.
First
That's what we did on the page. Yeah, we did. It's like when you told me that thing was a word and it wasn't. What was the word? I don't remember.
How can you think of that when it says New Monday on the board? I mean, I said it, but I mean, I wrote it on the board. All right, guys, I can assure you this, rather than giving you something like this on the test, I'll just simply pick out the ones I think you're gonna miss, I'll put those on the test, and I'll make them worth a fair number of points. Okay? I'm not saying I might do that, I'm going to do that. So, if you miss something, or if you don't understand something, you wanna make certain that you get to that understanding today, because chances are the one that gave you the trouble, if there wasn't any that gave you trouble, that's the one that you gotta worry about, because that's the one definitely will be on the test. Starting off with the first one, we got bright orange. We're comparing this back to a threshold frequency corresponding to medium intensity yellow. The medium intensity, of course, is irrelevant. The threshold frequency is just that, frequency. So it's the yellow that's important as far as whether or not the photoelectric effect will take place. Medium intensity simply refers to the brightness, and that will affect other things, but that won't tell you whether or not the photoelectric effect takes place or not. Bright orange has a less frequency.
Lower frequency.
Probably lower would be a better adjective here, okay, rather than saying it has less frequency, it would a lower frequency. It has a longer wavelength. It's a lower energy photon, again, would probably be a better way of describing this. The amplitude is greater because it's bright. You could say more amplitude, I guess you could say that. Number of photoelectrons you have as, number of photons is more. Because it's brighter, there's more photons, that's right. Number of photoelectrons is none, that's correct. Notice he didn't say that there weren't as many. He said there's none. That's what you want to be. You want to be direct about this. Total energy, you can't tell. Electron speed is not applicable since there are no electrons. Same in air and same in a vacuum. Okay, we found our first mistake. Bright orange, the way to do it as far as the photon speed is concerned, it's easier if you do it and think of it as a wave. So if I have this wave right here and this wave right here, remember we know that the waves of EMR will interact with particles of matter. Kyle, which one interacts more?
The one on top.
The one on top, the one that has the higher frequency, and so that's going to be the one that goes what, faster or slower through?
Slower.
Because it's interacting more, it takes it's longer. So when I ask you about photon speed, you're actually better thinking of it as a wave.
Okay.
So if you have orange light and yellow light, well, the orange light is going to be lower in frequency, and therefore
It's going to be faster.
it's going to be faster. There we go. Questions at all? To that?
Explain that again.
Yeah, the speed of EMR through a medium other than in a vacuum, it's all the same. That's why this is correct. You know, all light travels the same speed in a vacuum. The reason light doesn't travel as rapidly through a medium other than a vacuum is there's particles of matter, and the EMR the electromagnetic radiation interacts with those particles of matter. The extent to which it interacts is dependent upon the frequency of the wave. That's what we looked at back in the first part of atomic theory, part 1. We said the higher frequency waves, just in sort of intuitively, it looks like it would interact more, and it does, and therefore travels more slowly through the material. So if I'm comparing orange light to yellow light, I know orange light has a lower frequency and therefore doesn't interact as much, and therefore is going to be faster than yellow light. So when answering a question about photon speed, I stop thinking about photons, and I actually go back to thinking about waves. Why? Because it's just easier to picture and understand what's happening. Okay, so it's just really a matter of convenience. Okay, other questions? Okay, dim orange. Dim orange, we're going to again have a lower frequency than yellow, longer wavelength, lower energy photon, that's correct. A smaller or lower amplitude, that's fine, because it's dim. There is going to be, in deference to our English department, not less, but what? Fewer, right? Because you can talk about less water, but you don't say less apples, you say fewer apples. If you can itemize it, you should use the word fewer as opposed to less. No, I won't dock you points on the test if you do that, but I'm just pointing it out. So fewer photons, since it's a dimmer light. The number of photoelectrons is none, because we're not at the threshold frequency or above. Total energy is going to be less, that's definitely true. Electron speed is not applicable, faster in air, and same in a vacuum. Good. Any questions on dim orange? Yeah.
Why did the amplitude get?
Amplitude is tied to the brightness, so if I'm comparing a dim light to a medium intensity light, the dim light is going to be not as bright, therefore it's going to have a lower amplitude. Does that make sense? Mm-hmm. Other questions? We're going on everything else? Okay. Going for the dim yellow, the frequency is the same, the wavelength, the energy of the photon is the same, the amplitude is going to be lower. Fewer number of photons, or lower number of photons, you could actually say. The same number of photoelectrons, and that is not the same. That is not true. Okay. So, when the photons come down,